So we're trying to prove the two different shapes actually have the same area. And one thing that could help us out is if they compare in the same way to a third shape that is identical or the same for both of them. So what I'm looking at right here is this rectangle and this rectangle. And I notice that depending on exactly which one we're looking at, we could say that that this uh, this rectangle here is double the area of certain triangles. So I'm going to draw one of them on. Let's see, there's my polygon tool. So a polygon through that point, and a point somewhere on this line will have half the area of uh, that rectangle. So that triangle will be what, 9 point almost so 9.39 something inches. Okay, so, or if those are inches, whatever area units we're dealing with here. And we can drag that around to anywhere on there and it'll be true. Well, it turns out we wouldn't even have to keep it inside there though. We could be even a little more creative by putting it anywhere on this line, because that's still got this base and this height. So we're going to be able to use that. So I'll draw that on again, because let's just be as flexible as possible. So I can drag that anywhere I want to, and it can be useful. Okay, now what about a triangle with half the area of this square? Because, hey, triangles, at least it's the same kind of shape. Then we'd have to prove that it was actually the same. So I see that we could draw a triangle inside that square that would then have half the area of that square. Okay. So let's see. I don't see though that helps me yet, because I don't see how to prove that that this triangle and this triangle have the same area, because I don't see that they're congruent at all. So we need a way to get a longer side on a triangle that has the same area, or that has half the area of the smaller square, because that side's very long. So what could be the same? Well, one thing we can do to look for something that's the same length is use a circle. And it looks to me like, oh well, yes, because it's a square, like that comes out the same. Okay, that's going to help us. So I need something that is that length right here. Okay. So instead of on there, I'm going to try dropping a point on here and then drawing that triangle. And I'm going to stretch it over to this point. I'm going to stretch this up here to that corner. Okay, now it turns out, in fact, that it looks like I'm actually using the right angle. So I'm going to go ahead and do that instead. And it looks like here, to get that, I'm using the far corner. So instead of making another redundant point, I'll just use that far corner instead. Okay, so here's what I'm seeing. This side, and I'm going to start color coding because everything's better with color coding. So this side, I'll make it red, is the same length as this side, which we know because, squares. And I've got several in the same place there, so bear with me a moment while I get them all colored up. Overlapping sides make it tricky. Oh, I see. It's because I have overlapping polygons. Well, the point is you can see that those are sides of the same square, so they have to be the same length. This and this also are sides of the same square, so they have to be the same length. I'll make that green. Okay, so we've got two sides that are the same length from one triangle to the next. If we have that the third side is the same length, we'd know this. Well, that looks tricky to compare. But on the other hand, if we have that angle's the same, we'll have that side has to be the same. So this angle here is basically this angle plus a right angle. But this angle here that's between those sides is also this angle plus a right angle. So what we've got here is side, angle, side being the same as side, angle, side. Well, that's congruence. So now we know that this triangle is identical, especially in size, to this triangle right here. Okay, so now we know that this square and this rectangle that's half of the big square have to be the same. Well, now we can just use the same idea, and it looks like the far corner ends up being useful, so let's use that. So I'll drop that line and that line into place. Whoops, that's off. Okay, and then I can go ahead and draw the triangles. So I see one of them here, and I see the other one here. Okay, so again, this triangle is half of this square. This triangle is half of this rectangle. So if we can show how these two triangles are the same, well then we'll have that these two rectangles are equal in area. Okay, so we've got the big square, and then the medium square. So that's side something side. So side something side and side something side. We know the thing in between has to be an angle. Do we know it's the same? Yes, we do. Because again, we've got 90 degrees and then this little bit, or then this little bit and then 90 degrees. So we've got side, same angle, side, and side, same angle, side. So we've got congruence between the two triangles, which means we have, if we take double their area as the square or as this rectangle here. Oh, sorry, I didn't sketch that one back on. As this rectangle right here. Well, then we see that that this square really does have the same area as this rectangle. And so when we put those together, we get the big square. And so bam, the Pythagorean theorem, we have a proof. Hooray!